Hi there, welcome back. Let's talk about testing in Go. Well, testing in any development, right? So when you're writing your code, you should be able to test it. For example, you are creating a feature, it should be testable. So if you have gone for interview or you have seen some job description, you'll be seeing things like test-driven architecture. What that simply means is that you should be able to write test for your code and then build write a function or build your feature to test to match the test for your code, right? And but that's not what we're going to do here. So right now what we're going to do is good. I'm going to show you how testing work, because you don't just write a feature and then push it to production without testing it, and then clients now start seeing bugs or having issues with it, and then you now come and start trying to correct it. This can be draining. This can reduce the confidence of clients in you. Exactly. So this is what we are going to do. I'm going to write a simple function, test it, and then we can now start talking about how we can write functions we can't test. So the goal is to always try to write functions you can test so that you can test them. So now let's start with writing a simple function addition function addition. So you're going to write a simple func addition, and then we are going to return, and let's just keep a simple integer. So we're going to take here a, b, which are integers, and then what we're going to do, we're just going to return a plus b. This is simple enough, right? So if you check this, if we call this, we do a is equals to 5, let's just say a is equals to 2, b is equals to 3. So the function this function addition, it's just a comma b, right? A comma b, right? So a comma b, then let's log the response. So answer is equals to ans. Okay, answer is equals to ans. So if we run this, we do go run main.go, again we're expecting 5, right? So it's simple. Our addition function, we know what if we put 5 plus 5 we should get 10. It's that, so we can write test for this. So in writing test for it, we can just do let's create our test file here. Let's do this tests underscore main underscore test dot go. So we're going to use this to run the test, like the main test file, right? The main test file. So this is easy. You can just do from addition test addition. See, because you're in the test file, it can give you all the tests you want to write. So right now you can see we have this test addition here, so you can just go ahead and click that, and it gives you the whole my IDE gives me the whole method, how the function signature should be. If yours doesn't give you the function signature, then you have to write it out like this: test addition, this is the function signature, right? So now what we are going to do is call a unit test. Unit test is basically the most basic test you can do for a function or whatever your code you're writing. So basically you know that 1 plus 1 is 2, so you're going to write a test showing that whatever code you wrote is going if you put 1 plus 1, you're always going to have 2. So that's basically the basic test you can write to make sure that your code is working as expected, right? So basically, if we were doing a test-driven architecture, you would actually line up unit tests. Maybe you write a unit test for addition. 1 plus 1 should give you 2 before you go ahead and write your addition to match the unit test. So right now, let's go this. So what do? We are going to have series of tests that we're going to test for this addition. So we are going to just do tests. Let's do tests, and it's going to do an array of struct. So this struct, we're going to have like, okay, the name of the test. Let's do the name here is going to be string. So in case we are trying to iterate and then have different tests, we need to keep track of the different names of the test that we are trying to do. And then again, what does our additional function need? It needs a, which is an integer, and it also needs b, which is an integer, right? And then what do we expect? This is the expected result. Expected result, right? Expected result is also an integer, and that's all. So now let's fill up our array. So this is going to be an array of, so this is going to be an array of, the name is, let's call this one the first tests, first addition test, and then a, let's call a 1, and call b 1, so we know that. And then our expected result should be what? 2. So we can do this. So we can also copy this. Let's just make it up to like 2 or 3 tests, right? 2, 3. So second test, let's do year 10 and do year 80, and then we are going to have what do you call it, we're going to have 90 here, right? The same thing here. Third test, I'm going to do 1 1 0, and then we're going to have 90 here, and then we're going to have 200 here, right? So this is, we know 1 plus 1 is 2. We know 10 plus 80 should give you 90. Then we also know that 110 plus 90 should give you, 90 plus 10, that's 100, plus 100, that's 200, right? So we know this. So this is how test-driven architecture work. We already know what we expect from the function we want to write, right? In this case, we've already written the additional function. So how do we go around testing it? We are going to range through this test and then pass a and b into the functions, and hopefully the answer that we are getting from that function will equal the expected answer. That's how unit tests work. So let's get to it. So we do for, let's call this, let's blank the index, let's call this tt, right? The arranging through the tests, you're arranging through this test because you want to test all this one after the other. You're arranging through this test, and then this is what you do. So you're going to run your test in here. When you run through the test, you run the test in here. There is a method called run, and this run is expecting the name of the test. Like you want the first test for this first one, like this name. So you're going to do tt.name, and then it takes this, and it also takes a function. It takes the test function, right? Which you just take it there, and it's going to just populate the structure for you. It's not something you cram. Is there, right? So you just have to know what it's doing. So this is the name of the test, right? And then if you check, so now we are going to call our function here, our addition function. So you now do result. Let's do answer. Let's do answer here. Answer is equals to addition, and then we are taking tt dot a and then tt dot b, right? So now if answer is not equals to tt dot expected result, then there's something wrong somewhere. Then you're gonna do t dot error, right? T dot error, that's the test. That means this test has error in it. So I'm gonna do t dot error, and then you're just gonna do let's just do expecting. So what were we expecting? We're expecting, we are expecting tt dot expected results, but got but we are getting answer. So yeah, so this is basically your test here. This is everything you need to know about the test. So we can run it simply run it by just clicking play here, right? You play here, it comes in here, it's gonna run. As you can see, all the tests pass. We had first addition, second addition, third addition. Again, you can also run it with your terminal. We're doing go tests dash run all the tests in the whole directory, and then you should get, yeah, you see, okay, test passed. So let's just make one, sorry, let me just in case you need to see, let me see if I can zoom this out so that you can get to see. Yeah, you can zoom this out so you can get to see in case you are trying to code along, right? In case you're trying to code along. So now what we're going to do is that we're going to make one of the tests to fail so that we can see if it's going to give us this error expecting this. So now how do we make one of the tests fail? So we are going to do this. Let's just change this figure. Obviously 110 plus 9 is meant to give you 119, but we just leave the expected result as back as 200, right? So let's do this. We run this again, and then you see the test that failed. You can see the test that failed. Third addition test, which is basically the name of the test here, third addition test, and then it failed. Expected 200 but got 119, right? Because this test failed. It's supposed to, there is the 9 plus 110 should be 119, but what we said we are expecting is 200. So that's how test driven architecture work, right? So now let's go back here. So if we run this again, everything is gonna pass here. So now let's go back to our main, right? Like I said, let's try to write an additional test that we cannot test, an untestable additional test, right? So I'm going to do this. So let's imagine we introduce a time factor here. We introduce a time factor. Maybe we are trying to make it random in such a way a plus b is not just the way it is. There's also a factor that affects it. So for example, we can just do something like time t, and then we do time.Now. So if we do this test and then let's assume we want to do t dot nanoseconds, right? Let's just say we're trying to keep it as random as possible. So we're trying to return a plus b plus the time factor here. So we do know that anytime we run this test, right, you cannot really tell what time it will be. For example, I can be running this test right now and I'm going into the nanoseconds. So by the time I'm running the test, it might be 3 nanoseconds. By the time I'm writing that code for the test, it might be 3 nanoseconds. By the time I'm running it, it's 5 nanoseconds. So this cannot be tested. So let me show you. So we have already written our test, right? If we run this test again, like I said, there are different ways to run this test. So you can see it has failed. You can see from here expected to but got this. So now if you're looking at this, what it's doing is the nanoseconds is adding 2 plus the nanoseconds. Here expected 90 but got this. So you can see it's doing the nanoseconds plus 90. It's again here expected 200 but got this. So it's adding it up nanoseconds. But the thing is that we cannot keep track of time.Now. So how do we change? So if we needed to write something like this, how do we change it to be better so that we can test it? So instead of hard coding this time.Now here, why don't we pass in a t, which is a time, and then we go ahead and still return the time. So really it's basically the same thing, right? It's basically the same thing. Yeah, it's going to throw an error here because we need to pass in. So now in an error here, we can then control our time. So we can say fixed time is equals to let's do time.date, right? We can just do time.date, I think, time.date, and then because we are looking for nanoseconds, right? We're trying to get nanoseconds, so we can just do 2026 this was today's date. Today's date is about, oh yeah, this is January, February, March, April. This is 4. So today is 4. So we are doing 4, and then we also doing what do you call it? We also do what are we doing? Yeah, the dates, the day 20th, and then the minutes. We can just, all these things you can just do 0, 0, 0, and then seconds 0, and then nanoseconds. So yeah, we can put the nanoseconds here as let's say 100. Let's put 100, right? Let's put nanoseconds as 100. While we having error here. So this is the year, the months, the day, the hour, the minutes, the seconds, the nanoseconds, right? And then we now have time dot, sorry, with time is a time dot this thing, right? We have time dot UTC, right? Yeah, so this is it. And let me reduce this so you can see the full. So we can see it. So this is, we have a fixed time here. So this fixed time is time dot time. So you can just pass this fixed time in here, fixed time in here, and that works. So now if you look at this, you can see that nanoseconds is 100. So you can easily tell me what your nanosecond is. So even if you are writing a code that needs to use something like time.Now, so that you can use the current time to get the function. For example, you're doing let's do another fixed time is equals to time.Now, right? You can still pass it in there. And then how do you so if you pass this in there and then you run this code, right? And then you run this code, you're going to get what do you call it? Let's do go run main.go. You will get whatever. Say this is it. You cannot really predict this, but you can predict this. If you are using this one, you can predict this because you're going to do 100 plus 5, right? Because this is going to give you 5, this is going to give you 5, 2 plus 3 is going to give you 5. Then you now add it to the nanosecond part of this, and you're going to get, should be 105. Try that. See, yeah, you can predict that. So you can, this is how you write testable code. Is in that same lights, we are gonna, let's just copy this, right? Let's just copy this, that same light. We come here, we copy this, and then we just make sure this is our fixed time. This is our fixed time, and then we just pass it in here, fixed time, right? And then what we expect from, so now you're going to be doing, since you know that your nanosecond is, let's reduce this so we can have clearer picture. Since you know that your nanosecond is 100, so you're doing 100 plus 200, so you're going to do 300 here, you're going to do 190 here, you're going to do 102 here. So if you run this, let's clear this, let's run this. If you run this, this should pass. Exactly, that passes. So even if you are doing with this, you can see that passes. So I'm hoping you know what test is. This is what we call unit tests, right? This is what we refer to as unit tests, right? So you should be able to write codes and functions you can test, right? I'm sure you know how it is to write testable codes and how is it not to write testable codes. So play along with it and comment, reach out to me if there's any question. Please like and share. Who knows who you might be helping. Thank you very much.